Hi guys, welcome to Short Notes. In this lecture, we will be discussing two methods to draw bending moment diagram. Here we are having a beam with three concentrated loads of 10 kilonewton and at a distance of 3 meter and 2 meter from the edges. Now, for drawing shear force diagram, we need to know the reaction forces. So, the first rule is reaction forces. According to the equilibrium equation, the forces in x direction are 0, the summation of forces in y direction is equals to 0, and the summation of the moment in the beam is equals to 0. So forces in x direction, there are no forces in x direction acting, so it will be 0 automatically. The forces in y direction, there is a force, that is reaction of A plus reaction of B, that is equals to 0. If I am considering the reactions, so this is the A part and this is the B part. Now Ra plus Rb is equals to 10 plus 10 plus 10, that is 30 kilonewton. So it is 30 kilonewton. Now how to write the moment equation? Consider this beam as a representation of above problem. I am fixing it at A. So the first moment, the first 10 kilonewton will be dropping down the beam in clockwise direction. So it will be clockwise positive. Second 10 kilonewton, it will be dropping down to clockwise direction, then again clockwise positive. Third 10 kilonewton is also dropping down to clockwise and then clockwise positive. And then Rb dropping out down to anti-clockwise, that is anti-clockwise negative. So then for the summation of the forces, I must say that the first force 10 kilonewton at a distance of 3 meter, so it is 10 cross 3. Then 10 kilonewton at a distance of 3 plus 2, that is 5 meter, that is plus 10 cross 5. Then 10 kilonewton at a distance of 7 plus 10 cross 7. Then Rb at a distance of 10 minus Rb at a distance of 10 should be equals to 0. Now solving out this equation, we get Rb is equals to 15, and since from the first equation Ra plus Rb is equals to 30, so Ra is equals to 15 kilonewton. Now since we are having both of the reactions Ra and Rb as 15 kilonewton and 15 kilonewton, I must put it there 15 and 15. Now drawing a reference line for shear force diagram. This is my reference line for shear force diagram. I must draw the shear force. At point A, I am having a 15 kilonewton upward force, so I will be drawing a 15 kilonewton force. Then from A to the first loading point, I am having no alteration in the force, so the line will be going straight towards the first loading point. At first loading point, I am having a drop down of 10 kilonewton. I will be dropping down to 10 kilonewton, means 15 minus 10, that is 5. It will be 5 kilonewton. Now up till next force 10 kilonewton, I am having no force, so from this we will be having a constant force, that is 5 kilonewton. And at the middle load we are having a drop down of 10 kilonewton. I am going from 5 to minus 5, drop down of 10 kilonewton, minus 5. Now till the next point I am having the same minus 5. Now at the next point I am having again a drop down of 10 kilonewton, so I will be dropping down to again minus 10, that will be minus 15, kilonewton, and I will be going up straight up to the last point where Rb is equals to 15 is acting and Rb is 15 in upward direction, so I will be coming up back from minus 15 to 0. So this completes our shear force diagram. The first method to compute bending moment is the area method. In this method, we calculate the area of the shear force diagram and then plot the bending moment. I am considering this as a reference line of my bending moment diagram. Starting with point A, from point A to the next loading point, let me consider it at C. So I will be calculating the area under the bigger rectangle AC. The height of this rectangle is 15 and the length of this rectangle is 3. So the bending moment at point C will be 3 cross 15, that is 45, and now I will be having a straight line till 45. Now coming up to the next diagram, up to middle of the section, now I will be calculating the area of the middle rectangle, that will be 5 cross 2. 2 is the length of the beam and 5 is the height of the rectangle. Now 5 cross 2 is 10. Now I will be adding this 10 to the 45, which will be in the positive section of the shear force. 45 plus 10, that will be 55, and now I will be plotting it up to the 55 mark. Coming up to the negative side of the rectangle, now coming up to the negative shear force, I am having a rectangle which is having a height of -5 and a width of 2, so it will be -5 cross 2, that will be equals to -10, and now I will be subtracting my 10 from 55, that will be 45 again, so I will be going to this point and it will be 45 again. Now coming up to the last rectangle, which is also in negative, its length is 3 and height is -15, so it is, that is -45, and now it is going up to be -45. This completes our bending moment diagram very easily with area method. Now let us see the second method to draw the bending moment diagram. I name it as carry load method because I am carrying the load from one point to other point. Now I am having a reference line for the bending moment diagram as AB. On this reference line, the first load is Ra, that is 15 kilonewton. So I will be carrying this 15 kilonewton to a distance of 3 meters. That will be making it up 15 cross 3, that is 45. So the first bending moment diagram will be appearing at the first loading position, that will be of 45. Now at this loading point, another load 10 kilonewton acts, which is acting downward, so it will be -10 into 2, -10 into 2 for the next point. At next reference point, I am seeing that 15 kilonewton load has moved 3 plus 2, that is 5. So at the next point, 15 kilonewton load will be having a 15 into 5, and 10 kilonewton load will be having 10 into 2 minus, that is 15 into 5 is 75, and minus 10 into 2, that is 20, that is 70 minus 20, it is coming up to 55. So at next we are having a bending moment of 55 at the top. Now this 10 kilonewton load is again traveling at a distance 2, and previous 10 kilonewton load is traveling at a distance 4. So it will be -10 into 4 minus 10 into 2. Two 10 kilonewton loads, one traveling at 4, another traveling at 2, and 15 kilonewton now is traveling at 3, 2 and 2, that is 7. So it will be 15 into 7. This whole of the equation solving out to be gives us the next load, that is 45 kilonewton meter. So now at next point I am having 45 kilonewton meter. For the last RB, again a 10 kilonewton load is present. For this 10 kilonewton load, the distance is 3, so it will be -10 into 3. For this 10 kilonewton load, the distance is 5, so it is -10 into 5. And for this 10 kilonewton load, the distance is 7, so it is -10 into 7. And for Ra, which is 15 in positive direction, so the distance is 10, so it is 15 into 10. Now 15 into 10. Solving all of these equations, I get 0 as a resultant, so bending moment comes out to be at the last point, which is 0. So from Ra to Rb, bending moment changes from 45 to 55, again 45, and then 0. This solves out our bending moment diagram in the second method, carry load method. Now if I compare both of the results from carry load method and area method, there is no difference in the calculation of bending moment diagram. Hence both of the methods can be used appropriable to the conditions.